Okay, so just a quick video to back up what I covered in the lesson on nanoflow. So it's very similar to flow oil. Most people should have got by now to the point where they can connect to a device. We get an error because we haven't actually specified the device. We click on this emulator thing, go select a device. Well, we're going to be using an Arduino Nano. The COM port, it's always going to be the one that says RF Nano CH340 for us. We go OK, then we go connect. Now it's connecting to the Nano, and I can see the communication lights flashing. Takes a minute. Okay, success, connected to the device. If I look at the device and I click on output 13, output 13 is connected to an LED that's on the Nano. So I can actually see the LED going on and off. I can see that the analog ports, they're not connected to anything, so they're just getting spurious readings. 0 and 1, we can't use those because they're actually used for the communication with the USB, so you can see that there's something going on here because they're kind of grayed out. They look like there's something going on there. Okay, so that's how you connect. If you want to download your program, you use this one here. Okay, and if you want to play your flowchart, you use this one. Now I can't show you anything that's happening with the device now, so I'm going to disconnect from the device. But what I'm doing is I'm going to simulate device. So now it's simulating a Nano. So me clicking on these is actually not controlling my Nano. It's pretending that that output is on, and I can, if I make that, I make it an input, I can select that input, make that input be on, or I can change what is being received on my analog ports. Okay, so what we're going to do, we're going to have a little bit of a look at how we can incorporate variables into our program and subroutines. So I'm going to go to the flowchart tab so that I can draw something. I'm going to go start here. Okay, I'm going to call this start 1. So let's just call that start 1, and there's a reason why I'm going to call it start 1, and you'll see shortly. Okay, so what I'm going to do is I'm going to add the two analog inputs together. So each analog input is 0 to 15, 0 to 1023 here, you can see. And this one is 0 to 1023, and we're going to add those together. So I'm going to put in here a let command. Okay, and this allows me to define a variable if I want. So we've got no variable, so I'm going to add a variable. I'm going to call it A. So this is a place, A is a place where we can store numbers. And I'm going to set it to analog 0. Okay, so I'm going to go save. Now, all that does is whatever is on analog 0, it saves it in the variable A. And I'm going to add another one here. Another let command. I'm going to call this one, I'm going to add a variable, I'm going to call this one B. I'm going to go, this is analog 1, I'm going to go save. So now I've got two commands. Let A equal analog 0 and B equal analog 1, and I'm going to connect those together. Now what I want to do is I'm going to turn on output 12 if A is bigger than B. So then I can put a decision in here, get myself a decision. So what I'm going to do is variable A greater than variable B, and I'm going to save that, and I'm going to put this here. Okay, and I'm going to draw a line like that. Okay, if variable A, this one, which is analog, we know this is analog 0, then it's going to turn on output 12. So then I'm going to put an output box here. Output 12 is on, save. So in the yes situation, it's going to turn output 12 on, and in the no situation, it's going to turn output 12 off. And then we can drop that one down to there. Okay, so if A is bigger, which is analog, A is analog 0, if that's greater than B, which is analog 1, then we're going to turn output 12 on. If not, we're going to turn output 12 off. Okay, now then we're going to bring these back into a loop. So we want to come all the way back round there, and then this one the same. Can bring that one back round into a loop. Okay, unfortunately we can't move the, if we move this around you can generally get it to look a little bit neater so you can see what's going on. Oh, there we go, that's how I wanted it. So now the program's going to start, make A analog 0, make B analog 1, check which way they're round, whose is the biggest. If A is bigger, it's going to put output 12 on. If it's not, then it's going to put output 12 off. So now I'm going to make, they're both 0. Let's press play. So we go to the emulator button, we press play, and you can see they're both 0, so A is not bigger than B. Now if I increase B, A is not bigger than B, so the program is just going round this loop. Okay. If I increase A, as soon as A gets bigger than B, then output 12 is on, and as soon as I go down, it's off. Alright, so that's a fairly easy program. What we can do is if we click here, we can see the actual values of the variables. That's quite useful as well. You can even graph them so you can see them as a table like that. If you want to reset them, you hit that. Okay, now that's all quite useful. So I'm going to press stop. Now the great thing about nanoflo is that it will reliably run two programs simultaneously. So I can add another program in here and I can call this start2, and this can be doing something completely different, but the variables are global. What they mean, the global is that any variable that you identify here, you can use here. So I can put in a let command here, and I can say let's add a variable, call it C, equal variable A plus variable B. Okay, so now I've made C equal variable A plus variable B. So I'm using these variables in here. I can connect that up, and then all I really need is to just do a loop then, isn't it? So this will just continually loop through there. So when I go to the emulator and I press play, this is constantly adding the two together. So as I change this, if I make them both maxed out, then you have 2046, which is twice the value of that. Now that's one thing. Now the other thing I wanted to show you is how to use a subroutine. Now the subroutines are very simple if you know what's going on. So if I want to use a subroutine, so I want to call like a subroutine to do something. So let's say, well, let's make this bit the subroutine. So I'm going to go to my flowchart and I'm going to go subroutine here. Now it wants to know which one of the start nodes is going to be a subroutine. Now we don't want to make this one a subroutine. So let's make another start node. And I'm going to call this new sub. It's a new subroutine, okay? Save, and all this one's going to do is just cycle round, turning output 10 on and off. Okay, and then I'll put another one in here. Now going to output 10 off, save. I might just close this to give me a bit of space for now. I can put a delay in between them if I want, so I can put that 1000 milliseconds once, or I'll make it 500 milliseconds, half a second. Save, output 10 goes off, another delay, 500 milliseconds, save. Bring this one here, just make them a little bit neater. And now I'm going to wire them all together. Now, this start2, this will call this subroutine, but I have to tell it which one it is. So I go, okay, this is new sub 2, okay? I'll get rid of that, I don't know where that came from. So now, this start and this start will start simultaneously. This will run its program like it did before, and this one will start this new subroutine, which we'll call this. The program knows not to start this one because it's named in here, so this will always, this routine will only ever start here, okay, when that one's like that, okay. So what we could even do, then I can make a loop around here, so this just keeps running this one, and it loops around to here. So this will just continuously loop, flashing output 10 on and off when I hit start. So now I go press play. So this is output 10 is flashing on and off, and this will just go on forever. And even if it dropped out, this would make it go forever. So what I can do though is I can make this. I can get rid of this loop there, and I can actually make this run this maybe just 3 times and then stop. Okay. Now if this starts and then it calls this is stuck in a loop, so it's going to do it continuously. So we need to also get rid of this and put a stop in. Okay, now if I press play, this is only going to run 3 times, and then this is going to stop. Alright, so that was just a quick video about variables and subroutines. For your light detector, you will need to use variables to store each colour. Every time you illuminate with, let's say you illuminate with the red LED, then you need to store that in a variable. Then you illuminate with the blue LED, store that in a variable. Illuminate with the green LED, store that. So, and then you can do your comparison. Alright, that's that. Thank you.